Hello and welcome, ladies and gentlemen. We are here in activity 5.3 looking at investigating the centroid. So 5.1 was talking about a circumcenter, 5.2 was talking about an incenter, and now in 5.3 we're talking about the centroid. So it gives us a little definition here to lead off. A median of a triangle is a line segment that connects a vertex to a midpoint of the opposite side. So it says construct the three medians of each triangle. So you can see on what I did perpendicular bisector to find the midpoint of each side. Once I had located that midpoint, I connected it to the opposite vertex, and opposite meaning if here's my vertex, it's touching this side and this side, so the side that's opposite from it is the one that it's not touching, right? So I went ahead, again, you're basically just doing perpendicular bisectors for all these, but instead of marking the whole line like we did when we made the circumcenter, we're just going to mark the midpoint real fast, and then we're going to make these medians, okay? And we should have one point where we intersect. We should have a point of concurrency for all of these. You can see on all of mine, I do. Okay, so once you're done with those constructions, number 1 is good to go. Okay, 5.3 is fairly short. The longest part is going to be making these constructions and doing this part. Once you've done that though, you're good to go. So if you need to pause the video and do those constructions, that's awesome. You can double check yours with mine to see how they look. I'm showing all of them now. You can pause it however you need to look at those. Hopefully they look similar, okay? Now on to number 2. Make a conjecture about the location. Make a conjecture about the location of the intersection of the three medians of any triangle. Is the intersection located inside, outside, or on the triangle? So just like the last couple sections, I'm going to do acute, not equilateral, equilateral, obtuse, and right. Okay, and we're going to look at those individually really fast and see what conjecture we can come up with. So with my acute not equilateral, it looks like it's on the inside there. So I would just say that it's probably going to be on the inside for all of them. For my equilateral down here, it's on the inside. I'd say that's probably true for all of them. For my obtuse one, here we go, obtuse. It also looks like it's on the inside. Inside. And for my right triangle, also appears as though it would be on the inside. So I'd go inside once again. Okay, so now we get the actual definition of a centroid. The centroid is the point of concurrency of the three medians of the triangle. It is also known as the center of gravity. But you guys, also known as the center of gravity, if that's easier for you to remember, you can go ahead and remember that. But the word that you'll see most often and the word that you'll be tested on is this centroid here, okay? So now it says, consider the four triangles and the medians you constructed. Part A says, measure the distance from the centroid to each vertex of the triangle. Is the centroid always, sometimes, or never equidistant from each vertex? So I did measure these earlier just to double check before the video, but you can kind of tell by looking as well. These ones look all similar, but if you measure them, so this was the one that I had to double check with my ruler, okay? So from 8 to about 12, so that's about 4 centimeters. And then if you go here to this one, you can tell that from 18 to 14, that this one's definitely longer. So even though they kind of all look equidistant, just by looking at them, they are in fact not. Okay, the obtuse triangle we can tell is definitely not, because this distance is definitely shorter than that distance, okay? Same with the right triangle, we can tell that these up and down ones, like so these two they look like they're similar. I didn't actually measure these ones, but this third one is definitely shorter than those two, so I didn't worry about it. Okay, and then for the equilateral triangle, it does appear as though that is the case, that these are all equal. So just like the last couple, the equilateral triangle saves it from being a never to being a sometimes. And then when you explain your reasoning, you would talk about how the equilateral is the way it is, okay? You'd talk about how this equilateral, it is equidistant from, or the centroid of the equilateral is equidistant from all the vertices. Okay, now B says measure the perpendicular distance from the centroid to each side of the triangle. Is the centroid always, sometimes, or never equidistant from each side of the triangle? Explain your reasoning. So now we're looking to sides of the triangle, okay? Remember, we're doing the perpendicular. And this is just a sketch here, so these are not perfect perpendicular ones. But we could tell that while these two look like they're similar, this third one would definitely be longer. So we'd say never so far. This one is definitely going to be a never. I mean, imagine this distance from here compared to that distance. So that would be still we're at a never. We're looking at our right triangle. Okay, I'd say this one is pretty short, right? And then this one is going to be definitely longer than that. So I would say that this is also, we're still at a never, okay? And then the star and equilateral triangle is going to make us so that we are at a sometimes. You can tell that this is going to be equidistant from all of those. This is, and hopefully you're starting to catch on that the circumcenter of an equilateral triangle is the same as the incenter, is the same as the centroid, is going to be the same as the next one that we learned called the orthocenter. Okay, equilateral triangles, it's always in the very center. So this is always the case for equilaterals, which means that it is sometimes true of triangles because it'll be true for equilaterals, but not necessarily for any of our other ones. So here on to B, so it says we would say sometimes true, and we would say equilateral again, and you'd talk about how those are equidistant. So now it says the centroid divides each median, excuse me, there we go. The centroid divides each median into 2 line segments. So it says compare the distance from the centroid to the vertex and the distance from the centroid to the midpoint of the opposite side in each of the triangles of the graphic organizer. What is the ratio? So it's basically asking us to measure. Here we go. So it's asking us to measure this distance from centroid to vertex. So again, this one I already said was 4. And then it's asking us to measure from centroid to side. So this one looks like it's 2. Okay, so if I had to guess, now I'm going to do more than one to try and get a better guess at this, but if I had to guess, I would say that the ratio is going to be 2 to 1. This one looks like it's around 3. 3 would be right here, so it's like 3-ish, right? And then this one, from 12 to just about 18, right? This looks like it's about 6-ish. And please don't write 6-ish on your homework or on your tests. If you do it in this packet because you watched this video, this is the one time that it's going to be okay. All right, this is the one time. Don't do it again. But, okay, so then here we'd say that this one looks like it's 2. Like I said, this is the one time you could do this, so we'll just go ahead and write it out. Actually, this one, I'll say about 2.5, because that's close to 2.5. And then this one, sure enough, right around 5. Okay, so what is the ratio? So it's asking what is the ratio from centroid to vertex and from centroid to side? Well, we would say that it is 2 to 1, right? Because I had 2 and I had 4, I had 2.5 and I had 5 and I had 3-ish, and then I had 6-ish, right? So it's 2 to 1 or 1 to 2 depending on how you look at it. So I would say 2 to 1, and then to clarify, it would be from centroid to vertex, and then centroid to side, right? And so this was 2 to 1, and the 2 to 1 was centroid to vertex was the bit larger one, and then centroid to side was the smaller one, so larger, smaller. So I just wrote this so that there was kind of a guide here. So this is kind of what we're looking for. Okay? Sweet. So now I believe, oh, there you go. That was all of 5.3. 5.3 was kind of a short one. Okay. Like I said, the longest part was going to be the constructions there. So if you just watched this through and you still didn't do the constructions, pause it, do it, check it with mine, whatever you need to do. Yeah, I hope you guys have a wonderful day. I will catch you all in class. And yeah, I'll see you soon. Bye.